National Mathematics Day is celebrated every year on the 22nd of December to recognize and commemorate the achievements made by the great Indian mathematician Srinivasa Ramanujan. Srinivasa Ramanujan was born in 1887 to a Tamil Brahmin Iyengar family at Erode, Tamil Nadu. In the year 2012, February 26th, our former Prime Minister, Sri Manmohan Singh, declared 22nd December to be observed as National Mathematics Day to commemorate his birth anniversary. Even today, many schools across the country celebrate it with educational events, not only in schools but also in colleges.
This is the very famous Parthenon. This is the famous Pepsi logo. And this is the very famous Michelangelo painting. So, there is something in common between all these three things. It's called the golden ratio. The value of golden ratio is approximately 1.618. So not many of us know about the golden ratio or has heard about it. So then, what actually is this golden ratio? The golden ratio was a law that was found by ancient mathematicians to prove the proportionality that we commonly see around us in the nature.
This shape, a rectangle, in which the ratio of the sides a by b is equal to the golden mean 5, can result in a nesting process that can be repeated into infinity and which takes place in the form of a spiral. It is called the logarithmic spiral and it abounds in nature. Snail shells and nautilus cells follow the logarithmic spiral, as does the cochlea of the inner ear. It can also be seen in the horns of certain goats and in shape of certain spider webs.
My dear friends, I am Anandakrishnan T of class 9C. Today being the National Mathematics Day, to celebrate the birthday of legendary Indian mathematician S. Ramanujan, I would like to teach you all a maths trick. And the trick is how to find the square of a number ending with 5. Please keep in mind, for the application of this trick, the number should end with 5. So let's begin. For easy understanding, we will take a smaller number, that is 25. We will be writing the answer directly. So we will start from writing the last number, because in maths we always go from right to left. Step 1 is to write the square of 5, that is 25. In step 2, we will neglect 5 and take the remaining part of the number. Here in this case, the remaining part is just 2. In step 3, we have to add 1 to that remaining number. So here you get 2 plus 1 is 3. The next step is like this. We have to multiply the final number from the previous step with the original number. So that here we added 1, so we get 3. Now 3 into the original number, that is 2, so we get 6. And we add that 6 to the remaining 25, so we get 625, and that is the answer of 25 square. Now let us find out what is 335 square. Like the previous example, first we will write the square of 5. Then take the remaining part. Here it is 33. 33 plus 1 is 34. And 34 into the original number, that is 33, is 1122. Now we will write it before 25. And yes, we got our answer. It's so simple. Here's a quick recap. I hope you found this trick useful. Thank you and have a nice day.
We all see math as a subject, but there's more to it than we expect. Seems difficult before trying. What operations are we even applying? Practice is the only solution. Math isn't an illusion. It's a universal truth, mainly for the youth. Learning math is worth it, because it takes you far in life, I have to admit. So you better hurry up and finish that sum, awaiting for a future that's yet to come. Thank you. Hi, I'm Ashwik of 9C, and today we're going to have a look at the fascinating life of Shakuntala Devi. I was born in a Hindu Brahmin family in Bangalore on the 4th of November. My father, C.V. Sundararaj Rao, was a trapeze artist, lion tamer, tightrope walker, and a magician in a circus. At the age of 3, my father discovered my amazing ability to memorize numbers. At the age of 6, I proved my arithmetic capabilities in the University of Mysore. In 1977, I derived the 23rd root of a 201-digit number in just 50 seconds. My talents earned me a place in the Guinness Book of World Records in the year 1982. It was said that I had outperformed the fastest computers of my times. I disliked the title of human computer because I believed that a human being's mind could not be compared to a computer. I was an expert in highly complex mental arithmetic. My passion to expand the human capacity made me develop the concept known as mind dynamics. I hold the Guinness World Record for fastest human computation and is one of the best mathematicians in the world.
And today, on the occasion of National Mathematics Day, which is celebrated as the birth anniversary of the great mathematician Srinivasa Ramanujan, I will be showing you a working project on the types of polynomials, and this is very helpful to understand and remember easily the types of polynomials, whether they are on the basis of terms or on the basis of degree. So let me show you how it works. First, let me show you the types of polynomials on the basis of the terms. So monomials. You can see over here it is written monomials and the definition, which is the polynomials with only one term. And you can see over here some of the examples like 4x, 3 and 2y square. Similarly, if we rotate it this way, we can see binomials, which are the polynomials with two terms. An example as 4x square plus 9 and 3x square minus x. And if we turn over here, we can see trinomials, which are the polynomials with only three terms, like x cube plus 7x square minus 9. Now if we see on the polynomials on the basis of their degree, we can see linear polynomials, which are the polynomials with the degree 1. We can also see some examples like 3x minus 9 or y minus 2. And we can see quadratic polynomials, which are polynomials with degree 2, like 5x square plus x plus 7. And also there are cubic polynomials, which are the polynomials based on the degree 3, like 2x cube minus 6. So this is a helpful way to remember the types of polynomials, whether it's on the basis of your degree or basis of your terms. You can easily remember it and your teacher asks it to you easily.
Why don't we like maths? We dislike math because we think it's dull. We don't get excited about numbers and formulas the way we get excited about history, science, languages, or other subjects that are easier to personally connect to. We see math as abstract and irrelevant figures that are difficult to understand, but we should also realize the importance of maths in our lives. The mathematics of life is that add the odds, subtract the errors, multiply the victories, divide the obstacles, integrate your caliber, differentiate your weakness, inverse the destiny, simplify the struggle to solve your life. Mathematics may not teach us how to add love or minus hate, but it gives us every reason to hope that every problem has a solution. Math is really fun, but we find it difficult because we relate it less to our surroundings. So, let us all celebrate this day by trying to make math fun in our own ways.
Srinivasan Ramanujan was born on 22nd December 1887 into a Tamil Brahmin family. They resided in a small traditional home where his father worked as a clerk and his mother housewife. Not only was he kind and empathetic person, but he was also by definition a child prodigy. He mastered advanced trigonometry by the underage of 13 while discovering sophisticated theorems on his own. By 14, he received merit certificates and academic awards that continued throughout his school career. He completed mathematical exams in half the allotted time and showed a familiarity with geometry and infinite series. Despite leaving his college to pursue independent research in mathematics, living in extreme poverty and often on the brink of starvation, he was determined to pursue his true passion.
Hi, I'm Ramirez.
Hi, I am Miguel.
Deputy Collector. I have heard about the Indian Mathematical Society you have founded. Is there an opening in the Revenue Department?
Let me see the work you have done. You will get a job, but not in a place like a revenue department. Your genius is destined for more.
Iyer sent Ramanujan with letters of introduction to his mathematics friends in Madras, who then gave him letters of introduction to R. Ramachandra Rao, the secretary of the Indian Mathematical Society. Though Rao was first hesitant about Ramanujan and believed his work to be fraud, he was convinced after the latter discussed elliptic integrals, hypergeometric series, and his theory of divergent series. Ramanujan then wrote to G. H. Hardy in 1930. Coming from an unknown mathematician, the 9 pages of mathematics made Hardy initially view Ramanujan's manuscripts as possible fraud. Hardy recognized some of Ramanujan's formula, but others seemed scarcely possible to believe.
Ramanujan's letters were certainly the most remarkable I have received. He is a mathematician of the highest quality, a man of altogether exceptional originality and power.
Another famous accomplishment is the Hardy-Ramanujan number. It was when Hardy once went to meet with Ramanujan when he was ill at Putney that the Hardy-Ramanujan number came into being.
I rode in a taxi cab numbered 1729 while coming here. The number seemed to be a rather dull one. I hope it wasn't an unfavorable omen.
No, I think it's a very interesting number. It is the smallest number that can be expressed as the sum of 2 cubes of 2 different numbers. See?
Although Ramanujan is arguably one of the most brilliant mathematicians to walk the face of earth, he was plagued with health problems throughout his life. He was diagnosed with tuberculosis and had a severe vitamin deficiency and was confined in a sanatorium. He died in 1920 at the mere age of 32, but his legacy recommenced when his brother compiled his handwritten notes consisting of formula on singular moduli, hypergeometric series, and continued fractions. He truly had an astute mind and to this day motivates young mathematicians to think outside the box and to hone their true skill.
Hippocrates, father of trigonometry, study of angles and sides of triangles. Hippocrates, father of trigonometry, study of angles and sides of triangles. Alpha, beta, gamma, phi, psi, xi. Let's sing together so we can learn. Ooh. Hippocrates, father of trigonometry, study of angles and sides of triangles. Alpha, beta, gamma, phi, psi, xi. Let's sing together so we can learn. Ooh. First comes right angle triangle, opposite to 90 degrees hypotenuse, opposite to reference angle is perpendicular, adjacent to reference angle is base. Some people have curly brown hair, turned permanently black. Sine is B over H, cos is B over H, tangent is B over B. Cosecant quarter reciprocals of sine, cos and tangent. Tan is sine over cos, cot is cos over sine. Sine square A plus cos square A is 1. Oh. C square A minus tan square A and cos square A minus cos square A, both value is 1. These are derived from Pythagoras theorem. Ooh. It's turn of common angles, compound angle. Sine bracket A plus B sine A cos B plus cos A sine B. Sine bracket A minus B sine A cos B minus cos A sine B. S means same, so same signage, sine ratio. Cos bracket A plus B is cos A cos B minus sin A sin B. Cos bracket A minus B is cos A cos B plus sin A sin B. Remember, C means change, change in sine and cosine ratio. Tan bracket A plus B is tan A plus tan B divided by 1 minus tan A tan B. Tan bracket A minus B is tan A minus tan B divided by 1 plus tan A tan B. Cot bracket A plus B is cot B cot A minus 1 divided by cot B plus cot A. Cot bracket A minus B is cot B cot A plus 1 divided by cot B minus cot A.
Tan bracket A plus B plus C is equal to tan A plus tan B plus tan C minus tan A tan B tan C divided by 1 minus tan A tan B minus tan B tan C minus tan A tan C. Remember, last angle at front and ratio cotangent. Na 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 na. Na 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 na. Sine 2A is 2 sine A cos A. Also 2 tan A divided by 1 plus tan square A. Cos 2A is cos square A minus sine square A. Also 2 cos square A minus 1. Also 1 minus 2 sine square A. Also 1 minus tan square A divided by 1 plus tan square A. Tan 2A is 2 tan A divided by 1 minus tan square A. Cot 2A is cot square A minus 1 divided by 2 cot A. Sin 3A is 3 sin A minus 4 sin cube A. Cos 3A is 4 cos cube A minus 3 cos A. Tan 3A is 4 to 3 tan A minus tan cube A divided by 1 minus 3 tan square A. For submultiple, divide the angle by scalar of multiple angle. Transformation of product and sum of angles. Two sin A cos B, sin bracket A plus B plus sin bracket A minus B. 2 cos A sin B, sin bracket A plus B minus bracket A minus B. 2 cos A cos B is cross bracket A plus B plus cos bracket A minus B.
2 sin A sin B is cos bracket A minus B minus cos bracket A plus D. Sin C plus sin D is 2 sin C plus D divided by 2 times cos C minus D divided by 2. Sin C minus sin D is 2 cos C plus D divided by 2 times sin C minus D divided by 2. Cos C plus cos D is 2 cos C plus D divided by 2 times cos C minus D divided by 2. Cos C minus cos D is 2 sin C plus D by 2 times sin D minus C divided by 2. Na 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 na.